Algebra 2 students, for Miss Bell, if you missed this class, she's doing this right in class. Hopefully this helps, just in case anybody out there needs an extra review or a different review, or if you missed the class. I'm going to go through each one of these, and this is going to be a 2-video series. So look for the next video, just because it takes a little long to upload really long videos, so I like to split it up a little bit. Number one, we have, first of all, what is an algebraic expression for the word phrase? So we're given a word phrase and we got to express it algebraically. So for number one, 3 times the sum of B and F. So we have to have the sum of B and F. The sum means to add. We do that in parentheses, 3 times this, the sum of B and F. So we have to put 3 outside the parentheses because that would be multiplication, and that's what it would look like. Number 2, the quotient of 8 and the difference of x and m. So the difference, remember, is going to be subtraction. Quotient is division. So whenever you have a quotient of something, like if it said the quotient of 8 and 2, it would be 8 divided by 2. But we have the quotient of 8 and the difference between these two, whatever these variables would represent. So x minus m. And so I'm just going to have 8 divided by this. You could write it like this, 8 divided by x minus m. You'd have to put that in parentheses out. For number 3, what word phrase can you use to represent the algebraic expression? So here we're going backwards. You have an algebraic expression. Now you are going to write it as a phrase, a word phrase. So notice I have 5 times a number and I'm adding 2 more to that. So I started with, the way you most likely see it more times than not. And you could write this differently, as long as you're covering all this stuff. And I'll give you an example of that. I have 2 more than 5 times a number. Now you could say 2 more than 5 times x. Or you could say 5 times x plus 2. You could write it right like that. That's about all of them that I can think of right now, but those would work. For the next couple, what is the simplified form of each expression? Okay, we're doing PEMDAS. Please excuse my dear Aunt Sally. So anything with parentheses and exponents we're going to do first. So I have an exponent right here. I'm going to deal with that first. So 3 to the 3rd power, I get 27. I bring everything else down. Okay, now I did the multiplication and the division, all in this step. Now you could like slow it down and do one step at a time. You could do the multiplication and then do division and then add it. As long as you're adding last, because addition and subtraction is last, you'll be okay. So I took 27 times 32, and that gave me 864, and I took 12 divided by 4, and that gave me 3. And then I added the 2 up, and I get 867. For number 5, I work on the inside parentheses first. So 5 squared is 25, 4 squared is 16. Then I do the work inside the parentheses. That gave me 9. I'm just copying down everything else as I haven't used it yet. And then I did the exponent in the parentheses, which is 36. And then 36 divided by 9 comes first before addition. And then I add it, and then 13 times 13 is 169. Number 6, we're going to evaluate this when these letters equal these amounts. So all you do is plug in those amounts and then do your order of operations. You can see how I went from one step to the next, and you should end up with 198. Number 7, to which subsets of real numbers does the number 22 belong? That's going to be all of them. That's going to be, it's natural or counting. Whole numbers, those are, all the counting numbers except 0. Integers, those are going to be all negative numbers and all whole numbers. And then rational. and we're good. Because you could represent that as a fraction. You could put, 22 over 1. Number 8, to which subset of real numbers does the number square root of 42 belong? When you do the square root of 42, you get some crazy number that does not end. That's going to be an irrational number. What is the simplified form of each expression? Okay, I rewrote this to put the -8 in front. You're just going to use the distributive property. -8 times 2 is -16. -8 times a -9c is a positive 72c. That's as far as I can go. That's all I can do. Number 10, what is the simplified form of each expression? I'm going to put these two together. And I get 4.2. And then I'm going to put all my n's together, and I get 1.5. And that's it right there. This is a 2. What is the solution of the equation? What I did was I added 8 to both sides. And I did not finish this one. If you want to, you could multiply both sides by 7 to make it a little bit easier. I did do it on the calculator, and it comes out to 17.5. I might as well just do that. So when you divide both sides by 6/7, which is multiplying by its inverse, you'll get 17.5. X equals. One other way you could do is you can multiply everything by 7. So you end up with 6x equals 15 times 7. Give me 105. And then divide both sides by 6. Divided by 6. And you get the same thing, 17.5. Okay? That was just to get rid of the fraction. Whenever you want to get rid of the fraction, just multiply by the denominator. So that would bring this down. That's why it became 6x. And then 15 times 7 is 105. And then go ahead and go from there, work from there. And here I divided both sides by 6, and that's how I got the 17.5. Okay. I'll have you take a look at these on the next video.